Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based, of course. And as always, it is an honor and a privilege to be serving you here in my virtual classroom, as it is every day. My last video, if you kind of saw it, the audio actually didn't work, and I went a whole hour, a lot of issues of no sound. And I feel really bad about that and kind of frustrated over it. But this time, gosh darn it, I do have the sound in, and we're going to be getting going right now. I have a practice test going in for my Integrated Math 2 group. This is on polynomials, addition, subtraction, simplification, multiplication, couple word problems, degrees of polynomials, number of terms, things like that. I'm not going to say it's basic stuff, but it's straightforward stuff. It is the groundwork for everything else that we're going to be doing building up into our next unit, which regards mostly just quadratics and how you can solve and graph quadratics, and all this stuff is a pretense for that, really, and any other upper complex polynomials of sorts. So I'm going to jump right into it, guys. There are 20 questions here, and as you go ahead and watch this video, understand that if you want to find a specific problem, if you have this thing, number one, I'm going to give you guys a PDF of this practice test down below in the description section, and also you'll get a timestamp, a clickable timestamp for every single problem down below as well, 1 through 20. Some I think have just a couple parts to them, but I'm just going to call them 1 through 20, and I'm going to go in the order that they are asked. The PDF paper might cram your room a little bit when it comes to work, especially if you write everything that I write, or if you guys got to do a little more when it comes to work, but hey, I tried to save it just on one piece of paper, front and back, so forgive me for that. All right, let's go ahead and get started, guys, because that last hour video that I recorded kind of brought me down a little. So let's make sure that this time as I talk, it all comes into play. All right, let's start with number one here. Classify each polynomial by its degree and the number of terms. Part A is the degree, part B is the number of terms, either a monomial, binomial, or trinomial. Now, they don't have to restrict you to those things there. It could be a quadrinomial, 4 terms, or a 6-term, whatever, but this is only going to be one of those 3, it looks like. Now, let's start with the, it says let's start with the degree, so let's do that. I'd rather kind of do the trinomial first. Excuse me, the polynomial number of terms first. But when it comes to naming it, they do say the degree first. So that's there is kind of something to that would generally come into play. All right, so for part A, the degree. For the degree, guys, what you do is you look at each term. This is where I said I'd rather do number of terms first. There are 3 terms here. Okay, 1, 2, and 3. Technically, the term stops at the, plus isn't a part of the term, but I'm expressing that this term is positive. If there's a minus, I'd keep that in front to say that it's negative, so I guess that's why I'm doing that. So there are 3 terms here, guys, and the term's degree is based on adding all of the exponent values from your variables in each term. So here we have an x to the, I thought I saw something. Here we have an x to the 4th power and y cubed. We're going to add 4 plus 3 and we get 7. Here I don't see anything up with x and y, so we put, this means x to the 1st power and y to the 1st power. So 1 plus 1 is 2. And this is an x cubed and y to the 5th. Sorry if you can't see that. X cubed and y to the 5th, 3 plus 5 is 8. So based on this thing here, if we were to write this in standard form, which we're not going to this time, but you'll see we'll do that next time. If we were to write this in standard form, we would write this in descending order of degree by the terms, which means the highest degree term would be written first, which is this. The next highest would be written, which is that, and then the next highest would be this one. When it's written in standard form, the term with the highest degree is also known as your leading term, and in that leading term, that is where we state the degree of the polynomial. The degree of the polynomial is based on the highest degree term you have. This polynomial is of degree 8. We don't add these up after that. It's the highest one here. There are reasons behind it. We're not getting into those here, but this is of degree 8. So I'm going to call this an 8th degree polynomial. And more specifically, as it is 1, 2, 3 terms here, 1, 2, 3 terms here, this is a trinomial. Trinomial is a 3-termed polynomial. So this is called an 8th degree trinomial. This is called an 8th degree trinomial there. And that's it. All right, number 2. Write the polynomial in standard form and state the leading coefficient. So kind of going back to the idea what I said about leading term, the leading term isn't the one that's in front in raw form. You have to first put it in standard form. And standard form goes by descending order of degree. So let's look at these things here. Look at the degrees of the terms, and we will rewrite them so that they're there. So my first term here, 7x, actually is of degree 1 right here. because that is actually x to the first power. This doesn't have a variable, and if it doesn't have one in a polynomial, it's going to be of degree 0. If you're not sure kind of why that is, let me break that down really fast. Negative 4 can also be written as negative 4x to the 0 power. I include x because all these other terms have x in it. This is x to the 0 power to be of degree 0. Now, what does x to the 0 power evaluate as? X to the 0 power is 1. Any number to the 0 power, any non-zero number to the 0 power is 1, and negative 4 times 1 is indeed negative 4. So that's why this could be rewritten as this, not that we need to do that. This helps express the fact that it is of degree 0. A constant is of degree 0. So there's that. Negative 8x to the fourth is of degree 4 because the exponent for the variable there, and this is of degree 3. Now I want you to note here that the degree has nothing to do with the coefficient in front. And when we rewrite this thing in standard form in descending order of degree, that coefficient in front really doesn't matter when it comes to ranking. We do it in descending order of degree. So we are going to re-rank these things here. So the fourth degree term will go first, the third degree term will go second, the first degree term will go third, and the 0th degree term will go last here. Now as far as terms go, remember you carry the sign that's in front of it. So negative 8x to the fourth will be written first, negative 8x to the fourth. And then I have the third degree term, sorry that the arrows get a little confuzzled here, you don't really know what's next, plus 6x cubed goes next, plus 6x cubed. And then, although there's no plus in front of here, guys, keep in mind, because it's a positive 7x, we are going to be adding 7x here next. And finally, the minus 4 comes last. So this is standard form now, and this is how you really want to write all of your polynomials. Even when it's not asked to, it's going to be used more often than not in standard form for a good reason, how we can refer to it as a fourth degree polynomial, for example, and other things with it. Next chapter, when we do quadratics, the next unit, you're always going to want your quadratic term first, your linear term second, your constant term third, when it comes to the things that we do with it. Standard form is pretty awesome in that way. All right, leading coefficient. The leading coefficient, guys, is all about the coefficient of the leading term, and the leading term is negative 8x to the fourth. Remember, once you get it in standard form, then you know what it is. Now the negative 8 has some relevance here because negative 8 is the leading coefficient right there. The leading coefficient is negative 8. Again, you're not yet knowing what we would do with that leading coefficient or why it matters, or what the leading term or degree of the polynomial means and why it matters. That would be reserved for a future time. In quadratics, you'll start to actually get a little bit of instance on why it actually matters, and why it matters so much more than this 6, or this x cubed, or this 7, or this x, or this negative 4. They have relevance. This has a dominant trait to the overall appearance of your polynomial, though. It actually takes its essence and form based on that. All right, so that's number 2 here. Let's jump into number 3 and other problems like number 3. I think 4, 5, and 6 are a lot like this here. In number 3, we're going to find the sum, show all steps, write in standard form. So you can choose how you kind of want to go about showing your steps here when it comes to this here. When we write in standard form, remember, we're going to make sure that the leading degree, the highest degree, goes first and such. So if you want to rewrite what's inside in standard form first, that's up to you. I'm not really going to do that. I'm just going to find my highest degree terms and write those first when it comes to combining, and I'll just go from there. So right here we have the quantity, 3x squared minus 6x cubed minus 4 plus 5x. And we're adding it with the quantity negative 7x cubed plus 5 plus 4x squared. Now the fact that they quantify it will only mean something if there's something multiplied on the outside of it that's not a positive 1. And I'll tell you what, if I don't see anything out here, it's a positive 1. And if I don't see anything out here but a plus, that's also a positive 1. Case in point, these things aren't being affected. The parentheses are not affecting these in any sort of way, in that I could remove these from parentheses right now if I wanted to. In fact, I'm going to waste a step. To some people, it's wasting a step, but in using this step, I'm going to show you that this can be written the exact same way without parentheses and without harm. Now, when I add a negative 7, I might as well write minus. So instead of writing a plus here, guys, I'm going to write minus 7x cubed. And we are still going to be adding this 5 and this 4x squared. Now, finding the sum means we are combining like terms, which means terms that have matching variables with matching degrees, we will add the coefficients and maintain the variables the way that they are. X squareds stay as x squared, things like that. So what I'm going to do, guys, is I'm going to go ahead and find the highest degree terms here, or ones that are alike. I'm going to write them next to each other, and in the final step, I'll go ahead and combine them. This in-between step that I'm going to write isn't always really a necessary one. I'll show you it at least the first time, and we'll see if I prefer writing it after this. Okay, so I have the highest degree terms I see here are these cubic ones, these third degrees. I have a negative 6x cubed right here, negative 6x cubed. Now I'm going to go ahead and write the negative 7x cubed right next to it, because the bottom line is, guys, these two are going to combine. Negative 6x cubed and negative 7x cubed. Then let's find the quadratics, the x squareds. I have a 3x squared here. Remember, it's positive, so a plus 3x squared. And I'm going to combine that with this positive 4x squared here, ultimately, and we're going to get something there. And then I'm going to go ahead, let's change colors. I'm going to go ahead and find the linear terms. Here's one, a 5x. Is there another linear term, plus 5x? I don't see one. And lastly, I see two constants, a negative 4. I hope this audio is recording. I think it is. I have a negative 4 and I have a positive 5. Guys, you have no idea how frustrating it is to record an hour's worth. You probably do. Record an hour-long video, and play it back and realize, oh, look, the mic was turned on. Something in my software glitched out and it didn't work that way. But anyway, so plus 5 there. All right, so finally, in combining like terms, guys, here's what happens. The x cubed will remain as x cubes. I'm not going to get into great detail as to why that is in this particular video right here. But these remain as x cubes. I got to do negative 6 minus 7, and that is negative 13. So negative 6x cubed minus 7x cubed is negative 13x cubed right there. Plus, well, not always a plus, but 3 plus 4 is 7. So this will be plus 7 x squared. They'll stay as x squareds there. Plus 5x, that didn't combine with anything in the end. And then negative 4 plus 5 is a positive 1. So then I'm going to get plus 1. And that is the final result. Remember, this is written in standard form here. I'm going to go ahead and box that, and I'm going to get it all as one color eventually. But as you see me color code there, I am only combining like terms, and that ends up being the end result. My face is almost getting in the way there, y'all. Let's make it all black. There we go. There's the final result of that guy. Negative 13x cubed plus 7x squared plus 5x plus 1 in standard form. This is a third degree quadrinomial, 4 terms. The leading term is negative 13, and the degree of the polynomial, like I said, is 3. Not that you had to answer those, but I'm rehashing those. All right, let's do another find the sum, and then there'll be 2 find the differences. So after we just saw the last find the sum, this one may be arguably easier for people compared to the last one because it looks smaller. Only now we have some y things in here as well. So let's see what it means to combine like terms when we have multiple variables, and what it means to write it in standard form even when we have multiple variables. Okay, one more time, just like last time here, guys. The parentheses are really not affecting anything as long as nothing's multiplied out in front other than a positive 1. So one more time, I'm going to write this thing one more time without parentheses just to really reinforce the fact, guys. My students here are doing a unit test. You know, when you get to the later problems, we might be multiplying these two things as if there's no plus in between. Multiplying. Because there's no plus in between means we multiply. There is a plus in between here. So the thing that I'm reinforcing perhaps right here, right now, is this is addition. This is not multiplication. You wouldn't know the number of students that I'd have when teaching this kind of stuff that they'd learn this first, they'd do it correctly, and then they'd learn multiplication, and then when they get back to these problems, they almost ignore that plus outright. They see parentheses and they say, hey guys, let's multiply, and they ignore that. Make sure you treat the problem for how it's written, and this is addition. We are adding quantities, not multiplying quantities. Okay, I'm going to combine like terms. I'm not going to color code for, time's sake. I'm going to find the x squared terms first right here. That looks like my highest degree, and I'm going to go and add those. 2x squared with 3x squared. I think in the future, guys, the last 2 problems, I'm not going to put them next to each other, and you'll just see me kind of add them and go. By the way, something that you might want to do here, we can cross out ones that we've already used because we're only rewriting the terms right here. Know what I mean? 2x squared plus 3x squared. I'm going to go ahead and look at the xy terms next because the xy terms are also of degree 2. Remember, x to the first, y to the first, 1 plus 1 is 2. X to the first, y to the first, 1 plus 1 is 2. Xy's will combine with each other. Matching variables of matching degrees will combine. So 3xy minus 5xy would be written next here. You don't have to write the ones. I'm just showing you they're of degree 2. Then I got an x term. Let me cross this out. Then I got an x term here, minus x. And then I got a y term over here, plus 6y, which looks like that. Now I'll tell you about the reason why I wrote it in this particular order. You can get away, if you're in my class, you can get away with writing things of degree 2 in either order. It's up to you. But I'll show you why I wrote it in this order, ultimately. 2x squared plus 3x squared is 5x squared, because 2 plus 3 is 5. 3xy minus 5xy, 3 minus 5 is negative 2, so that's negative 2xy. these don't combine to anything, so I have a negative 6 and a plus 6y. And keep in mind one more time, guys, just because this thing has an x in it right here doesn't mean it combines with this, because this also has a y. You need to have matching variables as well. So only x, y's add with each other. Only x's add with each other, things like that. Now, why did I write it in this version of standard form if these are both of degree 2 and these are both of degree 1? If there's a tie, is there a specific way which it should be written? Sort of. If you wrote negative 2xy first, I don't think I'd be so opposed, and plus 6y wouldn't be so opposed. But you're going to see when we do some of the polynomial stuff down the line, especially with factoring next unit, it's preferred that you write things in, how do I say it? Not in alphabetical order, but you consider an alphabetically dominant variable if there's a tie. And what I consider is the alphabetically first letter to be considered the more dominant one. So put it this way. Let's put it this way. These are both of degree 2. But this x is squared and this x is to the first power. So I am going to be treating the x squared one more dominantly than the x. Even though this y is here to make it degree 2 and complete it, this alphabetically first variable has a higher degree in it. Therefore, when the tie is chosen, I'm going to choose this one to be first. This is an x to the first power. This is a y to the first power, but the alphabetically first variable I'm going to be considered more dominant here. Once again, you will want to have this down the line, so you might as well do it now, even if I'd accept either way that you write it. So most people would probably write the 6y first because notice it was further left in the problem than the minus x. I understand that. So if you wrote plus 6y minus x, whatever, that's good. This is more proper, more standard than not, though. All right, let's go ahead and move on, guys. Let's find the difference, show all steps, etc. Same thing, only now there's a subtraction instead of addition. And the one difference between this is, if you remembered, guys, last time I said parentheses don't matter as long as all that's multiplied in front is a positive 1. So if you see this first quantity that I have right here, all that's multiplied right there is a positive 1. Let's use a different color for this problem. Positive 1 right there, so that means I could just rewrite this as 9x cubed plus 11 minus 7x. Okay, so I guess here, negative times a negative is a positive, so we have plus 2x cubed plus 4x squared. Whoa, wait a minute. Before we go too fast, guys, we're not multiplying by a positive 1 anymore. So be very careful in what you write, because this term suddenly, this actually isn't going to be a plus. There's a mistake made here. So we go back and figure out what would have these things been if it were a positive 1 in front. I don't actually answer it that way. I know my textbook does. I know some of you students follow the textbook, so you might do that. You might turn this into a plus and therefore change all the signs on the inside. That's up to you. I instead prefer to distribute. As we're going to be distributing in a little bit, I prefer to say this isn't a positive 1, this is a negative 1. And although it won't affect the values, it will affect their signs. What happens when you multiply a negative 1 by a negative 2, and a negative 1 by a positive 4, and a negative 1 by a positive 3, and a negative 1 by a negative 13? The signs change. And that's what happens, guys. The signs change. And that's what we're going to have here. So we're going to change all these signs up. So when I rewrite this, it's going to be exactly like it is without parentheses, only now every sign is different. Instead of negative 2x cubed, it is a positive 2x cubed. And sure, you might have gotten that term right because the minus negative was right here. But check this out. No longer a plus 4x squared. Negative 1 times positive 4 is negative 4. So now we got negative 4x squared, negative 3x, and positive 13. Okay, so now this problem is no different than the last problems that we had now that we've written it without parentheses. But that first step is the, is the go-to that makes that a little more troublesome to begin with. Okay, just a little more troublesome to begin with. Okay, so just like last time here, I'm going to find all the highest degree terms first. I'm going to combine them. Only this time I'm going to do it without writing the in-between steps. See if you can follow along. Well, here's something that people might do here. Hey, I have an x cubed term. Let's box that. Let me find any other x cubed terms and I'll box them. Right? That way you can sort order that way instead of rewriting. I'm not going to box. And so, by the way, what they'll do next is like the x squareds. Let's triangle those and let's circle the x's so you can find matching shapes. I'm not going to do that. I'm just going to see if you can follow along with me here. I might cross them out this time. 9x cubed plus 2x cubed. Okay, 9x cubed plus 2x cubed is 11x cubed. I've combined all my x cubes. That's my highest degree set. And I'll cross them out to say that they're gone. I don't have to look at them anymore. If you want to cross them out, great. If you don't, great. Any x squareds exist? Oh, there's one. Anything else? Nope. Looks like negative 4x squared is all that's there. Combine that guy. Let's look for the x terms next, as again we go in descending order of degree. Negative 7x minus 3x. Negative 7 minus 3 is not negative 4. It's negative 10. So negative 10x. Cross those out. Notice how I'm using the sign that's in front to use those again one more time. And then 11 plus 13 is 24. So plus 24 right there. And that is in standard form. That is the final result after we have subtracted those things. Remember, the subtraction distributes the negative. Okay, I'm going to do that one more time in this problem here. See if you can understand the distribution of negative without me drawing all the arrows here. Basically, all these signs are going to change. From whatever they are, they'll become the other thing. Excuse me. So in rewriting this thing here without parentheses, becomes 5x squared y minus xy squared plus 5x minus 3. Then we're going to do minus 4xy squared plus 3. Remember, plus 3 plus 3y minus 7xy. Notice how I changed all the signs inside that quantity because we subtracted the quantity. For some people here, this is still kind of a wasted step. Some people say, Mr. Robinson, I can do that in my head. I'll subtract the negative when I do these. I don't need the parentheses and stuff. That's fine. Sometimes I do that personally. If I were to solve this problem, sometimes I just write it out. I just like it written out. I just like the non-parentheses perceptually. Just want to get them out of the way. Just get them out of the way. Make sure I know for sure what signs are what. All right, guys, let's do this thing in standard form, and let's combine like terms. Now, keep in mind what I said before when we combine like terms. You have to have matching variables with matching degrees. Not just the terms matching degrees, the variables match degrees. So my question to you, can we combine 5x squared y with xy squared? They both have xy's. Heck, one of the terms is squared in each, one of the variables is squared in each of them. Can that become 4, because that's minus 1? Could that be 4x squared y dealio? No, these cannot combine here, guys. The variables do not match in degrees. This x is squared, this x is not squared. Automatically, can't work. This y is to the first power, this y is squared. Once again, no. Those do not combine. However, these terms are both of degree 3. So when it comes to me doing this here, I want to find other things that match with it and write those first. Because I see right here, just super quick, degree 3, 3, 1, 0, 3, 0, 1, 2. So you can see the degree 3s here. They don't all combine. But you can see these are the first terms that I'm going to write in standard form. So which do I write first? Do I write an x squared y term first or an xy squared term first? If I do my proper standard form, because it's a tie. Remember what I said, the alphabetically first variable or letter should be more dominant, just as a general rule. That way you don't screw anything else up or you're not inconsistent. So I am going to find any of the x squared y terms and combine them. Oh, none exist. So 5x squared y is the first term. There it is. Not going to cross it out. Let's see if we can do it without that. Notice how I progressively do less work over time on these because I say, can you do less work over time? First times I teach it more, next times I just do more. Let's find all the xy squareds. Negative 1xy squared minus 4xy squared. That's it. So negative 5xy squared. Remember, these do not combine. Furthermore, they do not cancel by minus 5. These do not combine. They're separate terms here. Let's find all the degree 2 terms. 3, 3, 1, 0, 3, 0, 1, 2. Here's the only one. It doesn't combine with anything. Minus 7xy comes next. Okay? That's degree 2. Anything of degree 1? Degree 1's in the house. Here's a degree 1, 5x. Any other x's combine? No. Plus 5x. You'll notice a lot of things don't combine here, guys. Plus 3y. Nothing combines with that. Plus 3y. And then negative 3 plus 3 is 0. Those, I'll just write as canceling like that because they're actually gone. That's it. This is what remains here. So not much combined. In fact, I think only these two combined and the things that canceled combined. And remember, I wrote the x before the y, even though they're both degree 1. Well, because x is alphabetically first, so I treat it more dominantly. So that's proper standard form. That's things that do combine. A lot of things didn't combine. That was kind of the point of this last one I did there. And that's number 6. Okay, here we go. Now we have a word problem, and it says the cost of making x tables is given by 20x plus 1,100,000. The revenue made from selling x tables is given by 0.004x squared plus 15x. Excuse me. Write a polynomial for the profit for making and selling X tables. So here's the thing, guys. We have a cost polynomial right here. I'm going to call that C of X, if you know function notation. And then we have a revenue polynomial right here. I'm going to call that thing R of X right there. Okay. Just to kind of shorthand notation this thing. They want us to find profit. I'm going to call that P of X right here, just to make sense again of what we're doing. To write a profit polynomial or function in some cases, and I know in these problems they don't have the function notation. I'm doing it. To write the polynomial with function here, to find profit for something, guys, the profit of something, you take the revenue that you make and subtract the cost that you spend, right? Profit, net profit, is how much you earn minus how much you spend. If you make more than you spend, you have positive profit. If you spend more than you make, you'll have negative profit. And that's what happens here. So when we write a polynomial for this thing, for the profit, I'm going to go ahead and take my R of X polynomial right here and do 0.004x squared plus 15x. Notice how I quantify it? Notice how I quantify it here? It's going to be very important, maybe not for this one, but for the next one, because we're going to subtract the cost polynomial here, 20x plus 1100000 right there. Normally I don't put the commas, but it just gets a little, you know. Anyway, you subtract the entire cost thing, right? So that's important. Sometimes I'm just saying, hey, it's a substitution, so I group it up. Just, when in doubt, use your parentheses. But here, when you subtract, it's super important you subtract the grouping. You can't just say this right here and have everything be okay. Because suddenly this 1,100,000 is not going to be subtracted as a result of the upfront cost. Apparently, for tables, you got to spend a lot buying the tables or something, whatever it is, the warehouse, the stuff, and within the tables themselves, something. So, okay, let's simplify this thing before we do part B and finding the profit. So when combining like terms, guys, let's try and do this kind of in the next step. There's only one x squared term right here because I'm kind of running out of room. You probably are in your paper as well. And we have 15x minus 20x. So that's negative 5x right here. And then we subtract, remember this is a distribution of the negative. Now we subtract 1,100,000. So minus 1,100,000 like that. That's the simplified version of the polynomial after all subtracted. I'm sure you're okay if they don't say simplify. This first one is fine. But you might as well do this one here if you're going to be plugging in something like 20,000 here, because now I have less things to plug x into at this point. Let me make sure they don't say in thousands of tables or something. They don't. They just say making x tables. So find the profit for selling 20,000 tables. Now this model is what works for this guy right here. So we're going to go and use the model, substitute in 20,000, P of 20,000, meaning the profit of making 20,000 tables, selling 20,000 tables. By the way, what we're assuming here, guys, is we sell every table we make. So it says the cost of making X tables and revenue from selling. We're assuming we've made X tables and we've sold X tables. We've sold every table we've made. So the X's are the same here. So the profit of selling 20,000 tables is going to be 0.004 times 20,000 squared. Sorry, I'm going to leak over here. Minus 5 times 20,000. Yes, you probably have the same room issues as I do. Minus 1,100,000. Boom, like that. Okay, this is where all of us go to a calculator. Even I personally am going to not use a calculator just because I don't want to make a mistake. I don't want to spend too much time on this thing. So I'm going to go ahead, guys. Just give me 1 sec. I didn't get this one set up with my calculator in hand. So let me pop it up. Boom, boom, boom. It's some software. I'm using, it's like a TI-83. I don't know if you've seen me use this thing before right here. There's my TI-83 right here. So I'm going to go ahead and do 0.004. Oop, that didn't type. Hello. That's not 0.004, Mr. Robinson. All right, I guess I got to click this. 0.004 times 20,000 squared minus 5. Whoops, that's not a 5. 5 times 20,000. And my calculator will do order of operations with this stuff. It's not going to do 2 minus 5 here. It's going to do minus 5 times 20,000 minus 1100000. Boom. All right, what is our profit, guys? It is 400,000. I'm going to assume dollars. They didn't tell us it was in dollars, but I'm going to assume it's $400,000. I don't know if that's a fair assumption to make, but why not? So this equals $400,000 is the profit from selling that many tables from this model. Excuse me. I was going to say, are there questions on that? But I realized, so guys, I do distance learning, distance teaching, and I'm used to just talking to a camera, having people kind of not respond because I'm, they're turning off their webcam, their mic's not always on. So I was going to say, questions on that, guys? And I was going to sit here for about a minute and realize I'm not on Zoom. Okay, guys, here we go. So that was that number 7 all right there. I know it kind of leaked over into my number 8, but we're doing some brand new stuff, guys. No longer addition and subtraction of polynomials. Now we're multiplying polynomials. And I think the rest of the way is multiplication-ish for the last 13 problems that we have. All right, number 8, find the problem. We have find the product, which is the problem. We have 3x cubed times 3x cubed. Okay, to break this down in a couple ways, first of all of this is multiplication. 3x cubed means 3 times x cubed. And we're multiplying that, guys, with 3 times x cubed. Multiplication is commutative, which means we can reorder the items in this product and it will still be the same result, meaning I can put the 3's next to each other and do 3 times 3, and put the x cubes next to each other and do x cubed times x cubed right here. That might help when it comes to recognizing what the heck it is that's going on so you don't miss out on anything. Remember, we just came from combining like terms. A lot of people might mistake this and write 6x cubed or something of that nature. This is multiplication now, so sometimes doing a rewrite like this will really help you recognize the perception of suddenly everything's changed. This is no longer about combining like terms, not at all. Multiplication skirts right past that because all of this is multiplication. 3 times 3, guys, is 9, and x cubed times x cubed, it's not x to the 9th power. And here's the other part I'm going to break down for you. The answer is x to the 6th because we do 3 plus 3. Now, why do we add? Why do we add? X cubed in and of itself, guys, means x times x times x. This other x cubed also means x times x times x. What are we doing with this x times x times x and this x times x times x? We are multiplying them. And what is the result of 6 x's multiplied together? In simplified form, it is x to the 6th. If exponents are the number, if exponents can be rewritten as an expansion of the number of times that you multiply your base value, then you can condense the number of times you multiply some base value into an exponent. It goes back. 3 x's and another 3 x's multiplied together gives you 6. That's why it's addition. You count how many x's are multiplied. You count how many x's are multiplied, so you add. You do not. Now, here's the thing, guys. We multiplied x cubed with x cubed and we added the exponents. You know what a lot of people are going to do with the numbers in front here? They're going to accidentally add them as well. Be careful. 3 times 3 is still 9, guys. We didn't multiply this 3 with this 3. We multiplied x cubed with x cubed. That makes the exponents add for the very reason I just mentioned. This is describing multiplication. We just added how many x's got multiplied. Okay, I won't explain that in great detail anymore. I just want to, I want to make sure I covered that enough so that after we do that, it's good. All right, find the product of this guy. 5x squared yz cubed times negative 4x cubed y squared z cubed. Once again, this is not about combining like terms anymore. There is no plus in the middle or there's no minus in the middle here. It's all about multiplying here. And it's not a distribution of sorts because this is only a product. This whole thing's a product, right? Just like the last problem we did, this means 5 times x squared times y times z cubed times negative 4, normally if it's negative I like parentheses there, times x cubed times y squared times z cubed. Okay? We can reorder the multiplication if you so choose to. Maybe put the numbers next to each other. We multiply numbers with numbers. 5 times negative 4. Heck, I'm going to use parentheses for all these just to kind of be consistent. Now we're going to multiply, how about the x's together? Alphabetically first, let's do the x's. X squared with x cubed. It's almost like, so it's not combining like terms, but it's almost like finding things that are relatable in order to multiply. Notice how x cubed times x cubed is x to the 6th and we add. We're only going to add exponents if they have the same base. So in this case, the same variables in a way. So only x's will add exponents with. Only y's will add exponents with each other. The y and the y squared. And then the two z cubeds right here. Z cubed times z cubed, like that. Okay. 5 times negative 4 is negative 20, so we get that there. Now remember, exponents add the rest of the way as long as we multiply variables of the same base. X squared times x to the third, keep the base as x. We add the exponents. 2 plus 3 is 5. Okay? Remember, x squared plus x cubed would not combine naturally, but x squared times x cubed fuse, and we add the 2 and the 3. Y times y squared. Remember, guys, this does mean y to the first power. So this is y to the 1 plus 2 power. 1 plus 2 is 3. That makes it y cubed. And z cubed times z cubed, just like x cubed times x cubed. 3 plus 3 is 6. This is z to the 6th power. That is the final result right here. That is the final result right there. Negative 20 x to the 5th, y cubed, z to the 6th. Okay, so there's the multiplication. You don't always have to reorder these things to make them happen. Maybe you can just find them. 5 times negative 4 is this, and you go that way. And if there's a future problem like that, maybe I'll consider it like that. Okay, numbers 10 and 11 find the product. Okay, now we have a distribution here. There is a minus inside this quantity, which means we need to multiply what's outside of here with both terms, just like distributing the negative before. Now we're going to do that here. Distribution looks like this. If something outside multiplies with a sum or difference on the inside, you distribute by multiplying the a with the b and the a with the c to get a times b plus a times c. So this item outside of this quantity right here is going to multiply with x to the 4th, and it's going to multiply with negative 5y. Okay, so ultimately, I'm not going to write, this isn't the final answer, this is just what it looks like. Here's negative x squared y multiplying with x to the 4th. And then, by the way, it's probably, oh, I just had the word and I just dropped it. It's probably, not common sense, not appropriate. Oh, fine, I'll use the word appropriate for lack of a better term. It's probably appropriate to just put a plus in between. Even if your signs are negative, just go ahead and put the signs in where they are. Negative x squared y. And then here, this 5y is negative. Negative 5y. That way you don't accidentally repeat a negative somewhere, or you don't accidentally miss one where one should be. So every time you see me distribute with these things, guys, I'm going to put a plus in between. And then I'm going to treat the signs as they were with the bits there. Okay. So let's see if we can condense this one in short order. Notice this is a negative times a positive, so I know this part will be negative here. X squared times x to the 4th is x to the 6th. Doesn't matter if one was negative, one was positive. The variable, the exponents themselves are positive. 2 plus 4 is still 6. And then there's a y in that term. So this, guys, turned out to be negative x to the 6th y. The next one, I'll underline in purple right here. This one, let's write the number first. There's nothing else multiplied. Well, negative 1. Negative 1 times negative 5. So that's a positive 5. So plus 5. Find your x's, just an x squared. That's all that's there. And then there are two y's multiplied. Y times y is y squared. And there's that guy right there. That I'll underline in purple. That's what that one became. That's your final answer. That's the product. No, nothing could combine. And this is in standard form, as this is degree 7 and this is degree 4. So there's the final result of that guy there. Okay. All right, let's do this one with multiplication as well. Let's see if we can do this one without me writing the in-between step of this is multiplying with this. I'll just do it one by one and see if you can follow along with me. Now, I'm going to look at it more like this term is distributing into these, like that. Sometimes, most often actually, people prefer to actually see this in front. Remember, multiplication is commutative. I can just reorder that there. Do you mind? You don't mind, do you? I don't think you mind. In fact, I'm going to... Bye. We just got this right here, right now. Hopefully you're good with that. And by the way, oftentimes there aren't even parentheses around this guy either. This would just be out here, still multiplying, because there are parentheses right there. So, hey, even better. You'll see this a lot. You'll see this a lot. All right, guys, let's go ahead and multiply these things. 2x squared times 3x to the 4th. I got 2 times 3, which is 6. X squared times x to the 4th is x to the 6th, because remember, 2 plus 4. They add in the exponents. Okay? Now I got 2x squared times negative 4x cubed. 2 times negative 4 is negative 8. X squared times x cubed is x to the 5th power. Remember, not 2 times 3, but 2 plus 3. And then I have 2x squared times 3x. 2 times 3 one more time is 6, so plus 6. And x squared times x to the 1st, 2 plus 1 is 3. I got 6x cubed right there. Nothing can combine, and this is in standard form as they are written in descending order of degree. That is the final result. You would have gotten the same result if this thing was still on this side here. I just moved it out of the way. If that thing was still there. but I put it there just because, you know, you'll probably see it that way more often. This is a monomial times a trinomial there. Your end result should still be a trinomial, assuming nothing could combine early on. Nothing should still combine there. There it is. All right, next page, number 12. Number 12, we have a rectangle has length 5x plus 2y centimeters and width 3x minus y centimeters. We're going to write the polynomial for the perimeter of the rectangle, and we're going to simplify this polynomial completely and write in standard form. This one almost seems like it's out of sorts when it comes to order. It seems like this should have been more with the addition stuff. In a way, we'll be doing some combining like term stuff, but there can be distribution if you write this in a certain way. You don't have to. I'll show you what we're going to do here. I'm going to do a when in out, draw it out kind of thing. I'm going to go ahead and just draw out a rectangle, guys, so you can make sense of what it is when it comes to finding perimeter. So we have a length of perimeter of 5x plus 2y centimeters. I'll go ahead and write that on top right here, 5x plus 2y. And here's the thing about a rectangle, guys. Opposite sides are equal. If this is 5x plus 2y, then this is 5x plus 2y right here. All right. Now, on opposite sides over here, we have 3x minus y for the width, and here we have 3x minus y. I only learned about 2 years ago. This is stupid of me. I only learned about 2 years ago that width is always smaller than length. I thought that width was always left and right. No, width is just always smaller than length. Doesn't matter which one's left and right and up and down. I didn't know that. I didn't know that. A 7th grade student taught me that. A student who I tutored, because he said his teacher said that, and I looked it up, and it was true. Okay, so anyway, apparently this should be longer than that, apparently. All right, perimeter, guys. How do you find the perimeter? You add up the sides. You add up the sides, right? So what you could do, and I'm not going to do it this way. What you could do is write 5x plus 2y plus 3x minus y plus 5x plus 2y plus 3x minus y. What I'm going to do instead for the perimeter is I'm going to condense it a little bit to keep it a little bit cleaner here. There are two 5x plus 2y's here. There are two of them. So why don't we just double the content, double the amount, right? 5x plus 2y plus 5x plus 2y is the same thing as doubling 5x plus 2y. Same with the 3x minus y. Now keep in mind, they're going to add with those, but we're going to double that quantity. Plus 2 times the quantity, 3x minus y. This is why maybe it can fit here. We're distributing. Boop, 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 boop. Monomial with binomials there. So this is 10x plus 4y. Not that this maybe save time. I don't know. Not that this maybe save time. This is just something to put it in. Maybe this is why they wrote it here. Now the colors are kind of clashing here. Now you can't tell what's what. I'll make this kind of just a darker blue color right there. Okay, now we got to combine like terms right here with the x's and the y's, and we're going to get 16x plus 2y when all is combined. This is in centimeters. That's your perimeter of your rectangle with just x and y. We're not done here because now, so they say simplify completely and write in standard form. By the way, this is standard form because to me, the x term dominates the y term. Now they say find the perimeter, part B. Find the perimeter if x equals 3 and y equals 1. Okay, now we substitute. And by the way, guys, simplifying it does help you a lot more instead of substituting here. What if I plug in 3 for x, 1 for y? 3 for x, 1 for y. This is taking a while to do. It's a lot better now that I simplified it. They only have to plug in 3 for x right here and 1 for y right here. This is the perimeter, by the way. So this is 48 plus 2, which is 50 centimeters. The units of this, one more time, is in centimeters. And that's the end result of that guy there. Done with the problem. I'm moving on. No questions. I'm not on Zoom. All right, number 13, and you can see almost every single problem after this is going to have to do with multiplying polynomials of more than one term. Some will be special cases, some will be trinomials. Right now we're looking at binomials here. So number 13, we multiply. Simplify and completely and write in standard form, show all steps. Okay, guys, so here's what you're kind of trained to make sense of first. There was a first thing. Here's the next first thing, is something called FOIL. Something called FOIL. And FOIL is, it's called a mnemonic device, but it is an acronym for first, outside, inside, last. It's a way of teaching you how to multiply binomials together in order to get you to learn eventually how to multiply any and all polynomials. You can't FOIL every set of polynomials times polynomials, but they are training wheels for, I was going to say bicycles, for binomials that can get you into knowing how to do the rest. So F means first. That means we multiply the first terms of each quantity. We'll multiply x with x. That is x squared. We're going to add what's in between here, by the way, guys. Just like distribution of the other things. Plus, O stands for outside or outer, according to our book, outer. I say outside. We multiply the x with the 8, the two outside terms of this thing here. That's 8x. Plus, you got the inside terms, 3 times x right here. That's 3x. Plus, L stands for last. The last terms, 3 times 8 is 24. This is what foiling gets you when you distribute. So that way you're not confused as to what we distribute. You know what a lot of people would do if they learned this for the first, sorry, not if they learned it, if they were exposed to this for the first time, they would just do x times x and 3 times 8. You'd get x squared plus 24. Notice how you missed the inside terms there. Not the linear terms. So anyway, just keep that in mind when it comes to it. We multiply each term in one quantity with every term in the other quantity. All right, so x squared combines with nothing. That's an x squared. 8x plus 3x is 11x, and 24 remains on the outside. This quadratic trinomial in standard form is the final result there. X squared plus 11x plus 24. Learn it, love it, live it. A lot of these that you multiply, guys, the two inside terms will combine. That's not always true, but if you have a linear times binomial times a linear binomial like that, it will happen. It will happen. So there's the FOIL step there, guys. Let's go ahead and try it again. See if we can do it this time without me drawing all the arches and without writing FOIL out here. Let's try it one more time. FOIL, I'll say it. 5x times 7x, first terms, that's 35x. People mess this up suddenly. Squared. Let me go back one more time. X times x, people say x squared just fine there. They do. They understand it just says x times x. They go to x squared automatically in their head. You just did a lot of combining like terms things. If you got 5x plus 7x, it would be 12x. Heck, we just did ax plus 3x was 11x. Now you say 5x times 7x, people just do 35x. Boom, 35x. They forget the x squared. They forget that suddenly their 5 and 7 was much more important than the x's. They were so used to combining like terms, they forgot to multiply the x's. Let me just point this out one more time. 5x times 7x is 5 times 7 times x times x. These x's do multiply. It is an x squared. I'm trying to save people right now from making a mistake. Make sure you get that in. 35x squared. Outside, 5x times 4, that's 20x. Notice that has an x in it. 5 times 4 is that. 20 times x is x. Negative 2 times 7x is negative 14x right there. And it's a negative 2 one more time. Negative 2 times 4, that is negative 8. And that combines to be 35x squared. It looks like this will combine to be plus 6x. 20 minus 14 is plus 6. Plus 6x minus 8. That is the end result of that there. And finally, with this one here, we have 5x squared plus 6 times 8x minus 4. I have an inkling nothing will combine here because now this is an x squared. Some things change. So in foiling this one more time, 5x squared times 8x is 40. X cubed. X squared times x is x cubed. Okay? Yo. All. Sorry, I didn't mean to say yo. Like, I was going to say, yo, by the way. Yo, by the way, if you wanted to write this first to get it going, maybe do that, right? Do all these things first and then get it going. I probably should have done that for the last problem. I'm sorry that I did not, or the first problem here. Anyway, this is 40x cubed. Outside, 5x squared times negative 4, that is negative 20x squared. Bring the x squared with it. 6 times 8x is 48x, so plus 48x, and 6 times negative 4 is negative 24. Nothing combines. This is in standard form. You are good to go, guys. That is the final result of that one there. Moving on. I have 5 more problems to do. I think it's 20 in total. All right, Linda. Linda has a rectangular garden that's 3x minus 5 feet by 2x plus 8 feet. She wants to put a fence around the perimeter of the garden. If each foot of the fence costs $5, how much will the total fencing around the garden cost? One more time, it's another perimeter thing, so it's almost like the last problem we did. This question is a little different, though. I don't know if my students will be asked a question kind of like this on the test. I don't know. They don't say which one's the length and width, by the way, so I don't know which one's longer. I'm going to go ahead and put 3x minus 5 on top, and then 2x plus 8 on the bottom, or on the sides. Remember, guys, 3x minus 5 would go on the bottom. 2x plus 8 would go over here as well. If we do perimeter, we are going to double the bits here and combine like terms. So perimeter, don't know why I put parentheses there. I'm jumping the gun. Perimeter equals 2 times 3x minus 5 plus 2 times 2x plus 8. Remember, we're doubling the two lengths and widths and stuff that are there. So when we distribute, that's 6x minus 10 plus 4x plus 16, again, distribution. And combined like terms, we get 10x, apparently, plus 6. This is in feet. Okay. They say if each foot of the fence costs $5, how much will the total fencing around the garden cost? Now, the interesting thing about this, guys, some people might think, hey, remember the last problem where we substituted, a number for x here? Hey, let's plug in 5 for x here. Let's, 10 times 5 plus 6 is 56. It'll cost $56. You have to be careful. They never once said that x was dollars. And furthermore, they said each foot of the fence costs $5. This whole representation is in feet. X isn't in dollars, and X might be a portion of what's regarding feet, but right now X is just an unknown variable. I don't know what X is. They didn't tell us what X is here. X is just a part of it. Just like here, we didn't know what X was here. I still don't know what X is. What I do know is 1 foot is $5 worth. Basically, the dollar amount is 5 times more than the foot amount. So if I have 10x plus 6 feet of fence here, how many dollars will that be? 5 times the amount. It's going to be 5 times 10x plus 6. Remember, this is going to be in dollars. When I distribute here, that'll be 50x plus, not 6, plus 30 plus $30. That's a distribution. That's what the answer of this thing is. Mr. Robinson, that's not a dollar amount. That's an algebraic expression. Well, so was the feet. They didn't tell us what x was. Okay, now later, if they say if x is 2, then we could find out, oh, that's $130. And oh, that's 26 feet. They didn't tell us yet. So maybe there's a little trickery involved in that. You got to read a problem carefully and understand your units, make sense of what you're doing there. That one was a little tricky. I do acknowledge that. I don't know if I'll trick my students with a test question like that. No idea. But it's fair game, because it's a word problem that was covered on a practice test, so why not? It would be unfair if I didn't give something like this on a practice test and we didn't practice them, and then it was on the test. The other way around, yeah, we'll see. All right, number 17, we're going to multiply, simplify, completely, show all steps. Now, here's where I mentioned before, I think, unless it was the other video that didn't record any sound. I think it was the video where I didn't record any sound. Here's where you cannot FOIL. You cannot multiply a binomial by a trinomial by FOILing, by doing first, outside, inside, and last. Because the problem is, this term gets completely ignored. So we cannot FOIL here. Remember what FOILing is. Well, number 1 is for binomials, but number 2, it's the training wheels. It gets you into the place where we say, okay, now they've removed. Even for binomials, can you FOIL without foiling? Can you distribute properly in any sense? And here, so we distribute. Multiply each term in one quantity by every term in the other quantity. By each term, I mean the x and the negative 5x. Take this x, multiply with every term over here. X squared, 3xy, and 2. Then take the negative 5y and multiply it with x squared, 3xy, and 2. And of course, we add the result. Okay. So here's what this thing becomes if I write this out here. I'm going to multiply x with x squared, I get x cubed. X with 3xy, x times x is x squared, so this becomes 3x squared y. X times 2 is 2x. Bada boom, bada bing. Now, and here's where you got to be careful. This is a negative 5y. Negative 5y. Make sure every single time you do this, negative jumps in there. A lot of people just do minus the first time, and then they just do 5y times boom, 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 and they forget. Negative 5y times x squared. That is negative 5x squared y. Right? The y jumps in, the x squared jumps in, negative 5. They're all just kind of together as one. Negative 5 times 3xy is negative 15. X y squared, right? Y times y is y squared. And negative 5y times 2 is negative 10y. We're not finished. We still have to combine like terms and write in standard form. The x cubed term will go first. Remember, algebraically so, x comes before y. This is the highest. This is the largest degree I see. This is degree 3, 3, 1, 3, 3, 1. So because there's a tie in degree 3s, I'm going to take the x cubed term first, if you remember why I said that before. So x cubed comes first. The x squared y's will come next, but I got to combine them. So I got a 3x squared y minus 5x squared y. Notice this will not combine. That's xy squared. That's different. 3x squared y minus 5x squared y is minus 2x squared y. It's a negative. This is degree 3, so this comes next. It combines with nothing. That's minus 15xy squared. And then I have a 2x and a negative 10y that do not combine. The 2x term I'll write first because x is alphabetically first, minus 10y. That is the end result. All right, there it is when combined. 1 second. I'm going to slide ahead, see the preview. I'm going to preview this. Okay, I'm going to go back. Okay, guys, I'm going to do this problem, not fully one more time, but I'm going to show you another way that you can do this problem. If after you do binomial times binomial, if trinomials come into play with a binomial or larger, some people don't like having to write all this out like this, and it gets a little bit confusing for them. What they prefer doing instead is they do this kind of box method here. What they do is they, in a way, they construct a rectangle. They construct a rectangle like this thing here, and they write the parts. They write the parts of their quantities in separate portions of the subdivisions of this rectangle. Where are the subdivisions? Well, right here. I'm going to make 3 columns to represent the 3 terms in the 3-term quantity, the trinomial right here. And I'm going to make 2 rows for the 2 terms for this binomial portion right here. And I'm going to break these up into parts, okay? On the sides, I'm going to write an x and a negative 5y. And on the top here, I can write an x squared, a 3xy, and a 2. I'm not writing the pluses necessarily. I already know that they're positive here. Any negatives, I put negative. Now, what we're in effect doing here is we're finding the area of this entire rectangle by finding the areas of these mini rectangles and adding them together. And I call them rectangles because if this is x squared, then so is this, and so is this. That way I know, despite the fact I'm doing base times height right here, x times x squared is x cubed, I know that on this one, I'm doing x squared times negative 5y, because this is still x squared down here. You can't see it because my face is in the way. That's still x squared down here, if you know what I mean. So x cubed goes here. X squared times negative 5y is negative 5x squared y. X times 3xy is 3x squared y. It's the same numbers as before. 3xy times negative 5y is negative 15x squared y. So, oh, excuse me, I did something wrong. Negative xy squared. Now, why do people do this? Well, it saves you from writing a long strand of things. Especially, look, if you do these curve thingies, it can get a little cluttered, especially if it's a trinomial times a trinomial. Where does the third set go? Oh my gosh, that's a lot. Something else that it does that I actually am an advocate of for this that really helps is people often don't forget this negative anymore. You wrote the negative, you see this as a negative, you don't see it as a minus anymore that's in front of your term. They see the negative and they use it. And they focus a little more on the multiplication that's involved. Now you still have to combine like terms in the end, right? We still add this with this with this and combine like terms and you get the same result as we got last time. But this is another way of distributing them that we can do. Set it up as a 2x3 if this is a 2x3. You know what I mean? And you do it that way. Anyway, that's another version of what you can do. I'm going to go ahead and move on. And the last 3 problems that we have here, numbers 18, 19, and 20. These, for some people, are easier than the last problem that we just did, and for me it is as well. But you just got to make sure you do it correctly here. Multiply x plus 7 quantity squared. Okay, let me get out of the way what you do not do. You do not distribute the squared into here and call this x squared plus 7 squared, which is x squared plus 49. You do not. You do not do this. Do not. If you are my student, listen to me. Despite the fact that you squared 7 correctly, and despite the fact that 2 of the 3 terms are correct, if you do this on a test, you will get 0 credit for the problem. You will not get partial credit because you have been warned about this one, because you are misconstruing the idea of the math. There's one thing to miscalculate. There's another thing to misordeal this one entirely. So I'm warning you right now, if you're one of my students. I'm not threatening you. Okay, yeah, I am. It's a threat. I'm saying it with kindness. Please don't do this. It's been covered. This video is covering it. You're practicing it. Please don't do this. We do not distribute exponents into sums. We distribute multiplication into sums, not exponents. A square means multiplying something by itself. So the conventional way of doing this problem would be doing x plus 7 times x plus 7 and foiling it. I'm going to leave that to the side for a moment. I'll do this in the end to confirm it's the same answer. What we have learned in class in a textbook. So this is what's called a special case because it's something times itself. And what happens is the format of this always appears the same in the end. If you take some first term, add it with the second term, and square it, what happens is the first term and last term are actually squared and they're added, but there's a middle term that you're missing entirely, which is double the product of those two terms that you have, double A and B. You're missing an entire middle term that is crucial to these problems that we do. We've practiced them, so we should do them. So I'm going to use this format for this one just to see if you can get the comfort of if you like it. You don't have to do it this way. But basically what we're doing here, I'm basically treating x as A and 7 as B. And you essentially plug them into here. It's like a substitution, right? So this becomes x instead of A squared plus 2 times A, which is x, times B, which is 7, plus B, which is 7 squared. Yes, x squared plus 7 squared is in there, but no, it's not a distribution. You're missing this term here. Hang on, my computer's running low on storage here. I might be running out of room. Let me see how much room I have here. I know I have a few problems left, but if this video stops, that'll be a problem. One sec. I got 3 gigs left. Let me delete some. Sorry, guys. This is kind of weird and awkward. Let me pause this video. I'm going to delete some stuff. Okay, I'm back. I have more than enough room now. I had stuff in my recycling bin that was gigabytes huge. So that was pretty easy to do. It was old videos I already uploaded. So, all right, I'm good now. Here we go. So x squared indeed is x squared. 2 times x times 7, that's 14x. So plus 14x. And then 7 squared there is 49. And that is the end result of that. You doubled the product of the 7 and x, and then you squared the 7 there. So, oh, Mr. Robinson, it's like x squared plus 49. Yeah, I know, but you went about it with this misconstrued idea. And it's something I want to penalize in the way that, because, you know, I want to stop you from doing it. And one way is to threaten you with not giving you any credit on a problem like that. So I think that's fair game to say. Because you want to know how exponents work, and they do not work through distribution. Multiplication is a completely different thing. All right, x plus 7 times x plus 7, if you wanted to FOIL instead, you would get x squared plus outside 7x plus inside 7x plus last term is 49. The 7x's, you can tell, are the same, so you double them, right? That's what this comes from, doubling. And then you get x squared plus 14x plus 49. So the safe way for a lot of individuals, honestly, is just expand it out. And you know what? I have no problem with that. I have zero problem with that. For people that know what's going on here, you can kind of get a mental approach. Cool. Maybe you'll benefit more from doing that. I do prefer everyone knows that this means expansion. And if expansion is your safe way of going about it, always do it this way. There's nothing wrong with doing that. So these special cases don't have to be acted as special cases if you just expand it. Just do not distribute. Do not distribute. Same thing here, guys. Do not distribute the square into there. Okay, so what could we do instead? We could expand on number 19 and write it as 3x minus 2y times 3x minus 2y. And of course, I will happily show you that end result afterward. But let me go back to that special case idea and show you that if 3x is treated as a and negative 2y is treated as b, well, here, you can do this one of two ways. I'll treat 2y as b, and I don't know if you saw before that I wrote that a plus b was the thing, but a minus b squared is going to be the same thing, only the middle term is now subtracted like that. B squared is still added, because you're going to do negative 2y minus times negative 2y, that's positive 4y squared, so still positive. The inside term, this linear term, however, not linear, this inside term is subtracted though. So I'm going to treat b as 2y, just 2y, and I'm going to treat a as just 3x. Those are parentheses, by the way. Okay, so how do we do this? Now, by the way, parentheses will be important for this thing here. So when I do a squared, I got to square all that, which is 3x. 3x times 3x. I don't write 3x squared like this, because now the 3 is not getting squared. Square the whole thing. When you substitute, use parentheses. Square the a minus double the product of a and b. Remember, b is just a positive 2y now, because I used the minus in the formula. And then plus 2y quantity squared like that. Now 3x quantity squared, guys, that's 3x times 3x. That's 9x squared. Don't forget the squared. And 3 times 3 is not 6, right? We're not adding the things that we're multiplying. Minus 2 times 3 is 6 times 2 is 12. And we got an xy. got an xy siding here, guys. Plus, same thing as last time. 2y times 2y. 2 times 2 is 4. Y times y is y squared. 4y squared. Folks, this is one of the instances here where this standard form is going to be so much more preferred if you write it in this order. Note, all of these are degree 2. Degree 2, degree 2, degree 2. It's a tie. But this is the order that you should write it. This here, the x squared term first, the y squared term last, and the xy term in between. Okay, this is the way that you should write it. When we do factoring and go backwards from this into something like that, or something like that here, you're going to want this form. I promise you're going to want this form. So try and write it in that order. All right, let's double check this. Let's see if we got it correctly down here. I'm going to do, I don't know why I wrote that in red. FOIL, 3x times 3x is 9x squared. 3x times negative 2y is negative 6xy. Negative 2y times 3x is negative 6xy. Negative 2y times negative 2y is positive 4y squared. A negative times a negative equals a positive. Negative 6y minus negative 6xy minus 6xy is negative 12xy. You get back where you are. So it still works out. Once again, you can binomial expand and then FOIL. Totally up to you. Totally works out. Get the same answer. Good. You see both approaches. It works out. There's one last problem we have here in multiplying. Simplify completely, write in standard form, show all steps. Okay. Let me first give you the identity of this form here where we have something that's adding with something else and that same thing that's subtracting with that something else. A plus b times a minus b. That's what we have here if 5x were a and if 4y were b. The end result of these ones, guys, becomes a squared minus b squared. This is what's called a difference of two squares. This is one where ultimately, and I'm going to do this version first, you just square the first guy, you square the last guy, and you subtract them, and then you're done. So let's try that here. If 5x is like your a and 4y is like your b, I'm going to substitute 5x for a, use parentheses, 5x squared. I'm going to square my b guy, 4y. It's going to be squared, and I'm going to subtract the result. Okay. It's always going to be subtraction in between. Doesn't matter if this has a negative, whatever. It's going to subtract the result. 5x squared is 5x times 5x. That's 25x squared. 4y times 4y is 16y squared, and we subtract, and that's the end result. Boom, 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 right there. You don't have to write the in-between step right here unless you don't know what you're doing. When you square that 5x and you get that there. That's the end result. Now, Mr. Robinson, this is already set up to FOIL. Why don't I just FOIL it? Yeah, go ahead. That's fine. Go. I'll do it too. Now, when I FOIL it, 5x times 5x is 25x squared. 5x times negative 4y is negative. What is that? Negative 20xy. 4y times 5x is plus 20xy. Notice I'm going to write the x term for the x first and the y second to make sure I know what can combine. Right? That's why we do the alphabetically first thing. And 4y times negative 4y is negative 16y squared. Now notice what happens when we combine like terms in the middle, because they can combine. I got a negative 20 plus 20, that becomes 0. So negative 20xy plus 20xy actually cancel out. And what's left? 25x squared minus 16y squared. So what happens on all these problems, guys, when you have the a plus b, a minus b thing, is the middle terms cancel out each time. So when you ask, Mr. Robinson, can I just FOIL it? Sure, yeah. Oh, by the way, I didn't do this thing here. Sure, you can FOIL it. You know what's going to happen is you're going to waste time with the two in between steps. They're just going to cancel themselves out. And heck, you know what some people are going to do? Negative 20xy plus 20xy, they're going to write negative 40xy. They're going to make a mistake there. So, sure, yeah, go ahead and do it. Just be careful. It'll take a little more time, and be careful. If you recognize this property here as a difference of two squares, you can go ahead and square it, and you'll be right on your way. You can give me problems right off the bat. I square, subtract, done. So there's efficiency in this. There's recognition of what happens in this. If you did it with me in class, you'll know what's up. And then you're done there. All right, guys, that is it for this practice test here. Hopefully I covered everything for the do's and don'ts here. Do not distribute the square into those little bits, as I mentioned before, of the polynomials. Make sure you multiply something by itself. But hopefully I covered everything in great detail. My students who are taking the test here, it should follow kind of a similar accord when it comes to the kinds of questions you're expected to see. So practice that one out. Take a look at that. I'm saying this too late, but if you watched my video as you did your practice test, don't erase your old work. Go ahead and use pen and go over it. And so now you know what you got to study up and do, right? And consider test corrections afterward. Think about the mistakes that you want to try and avoid. Think about it like, if I'm doing test corrections before my test, on my practice test. All right, guys, I'm hitting the 1 hour, 10-minute mark here in just a bit. I'm glad it looks like this audio is recording, so this thing will be uploaded with sound, unlike the previous video that would be uploaded. Take care, guys. Have a good one.